Welcome back to part 3 of the tutorial series on Catatumbo. My name is Sai Pulla Bhutla. I am the author of Catatumbo. In the last session, we actually did some sample code to actually persist some entities to the Google Cloud Datastore using Catatumbo framework. I have demonstrated how you could set up your Maven-based project, how to connect to Google Cloud Datastore. I also showed how you could use the data store emulator for development purpose. And then we created an entity and did the CRUD operations. And then we learned about a handful of basic entities that are provided by the Catatumbo framework. In this session, we're going to talk about entity groups. Entity groups are is a feature provided by Google's Cloud Data Store to organize your data into hierarchical structures. For example, uh, if you have an entity called user and you want to store all the user information into under this particular user entity. For example, user has emails, and emails could be children of the user entity, or user maintains his favorite stock symbols. Those could be also children of any user entity. Um, or you just want to have multi-level categorization of your products that you're selling online. You could use entity groups for that as well. So the entity groups and ancestor keys, they are pretty much similar or same. So ancestor keys are what form the entity groups. In the last example, let's go back to our last example. We just have, we create an employee entity. This entity by itself is considered as a root entity because it does not have a parent. Um, an entity, of course, can have a parent, in which case um, it has an ancestor and it is a child of some other entity. So let's modify our example to create a child entity for our employee entity. Typically, you would use it to store related information. So let's say we want to maintain our the time off request that employee puts in um, as a child entity of the employee entity. So let's go ahead and create a new uh, class to for the time off. This is going to be another model class. All right, and in here we will have, let's just take a calendar, I guess, for the date. um, we typically need just a date. We don't need a date and time, but since so we could either use a string type or just a calendar type, or date type, either way. And then we'll just add int hours, how many hours the employee took the time off on a given date. So that's going to be our second model. We will work through this, but let's go back to our employee class and add a couple more fields here, or just one more field actually. So let's say I want to get the entire key of the employee. So data store key is an interface provided by the Catatumbo framework. When you have this field in an entity, this field will be populated. as needed. For example, if you are inserting an employee, uh, the data store key will be populated with the entire key of the employee. Now, in order to make this work, you need to annotate it with the key annotation. So com jmethods catatumbo key. Once you do that, of course, you can say you have to provide the setter and getter methods. So let's go ahead and add those. So I got the setter method. Let's also add get key. I'm going to regenerate my toString method here. All right. So now if we are currently set to, when we run the app, we're going to create a new employee entity, and it's going to be inserted into the data store, and we're going to see the input and output printed to the console. I'm going to go back to data store and clean up our employee entities just so we have a fresh start. So let's go ahead and delete. So there are no employee entities. Now let's go ahead and run our app. All right, so now if you notice, our employee still got an ID, which is a random UUID, and then we have a key of uh, this is the entire key. Keys are unique within the entire Google's Cloud data store. It doesn't matter if it is just your data or someone else's data, and they have several components. Key has, for example, a partition ID, a project ID, which is our, and then the entity's kind, and then the actual ID we supplied, and then if the entity has some ancestors, they will also be part of the key. Uh, a namespace could also be part of the key. Namespaces are something that we will cover later in the tutorial. So that's the entire key for our entity, which has a bunch of information. So it could be located uniquely within the data store. And then we still have our properties. So you can use, once you have the key added to your employee, you could use the getter method on it, and then use it to set on a child entity. For example, in time off class, now we can go back and say, okay, who requested this time off? So let's add a parent key here, which will also be a data store key object. And then in order to uh, annotate or tell the Catatumbo framework that this is a ancestor key or a parent, you just need to mark it as a parent key. All right. Now let's go ahead and generate the getters and setters. And let's also generate toString. Now let's do our basic stuff. Time off is an entity, and then we also need an ID for this entity. So let's just use a auto generated ID and mark it as identifier. Okay, so our time off entity is now ready, and we should be able to create a time off entity, set its parent as one of the employee entities, and then persist it. So I'm going to just create a brand new class now to demonstrate with a main class. So let's just call it, since we are doing session 3, we're just going to call it part 3. And we just want a main method there. I'm going to just copy paste some of our stuff. We need the entity manager. And let's get the initialized entity manager. Okay. Now let's say we want to insert a time off request. So let's just say private static. All right. Now, in order to insert a time off, we of course need an employee object. So let's just load our employee by ID. So this is the employee ID. We're just going to call it parent or requester, however you want to name it. And we're going to load that employee first and the ID. So now we're going to say time off set employee. I mean, right now my method name is called employee key, which is fine. So we'll say requester dot get key. So what we are doing is that we are setting the employee's full key as the parent key or ancestor of the time off entity. And then let's populate the rest of the properties. Set date, I'm just going to say calendar. I'm not going to worry about any time, so it's just going to set now as the date and time in the data store, which is good for our example. And then the number of hours, we're just going to say 8 hours is the requested time off. Now let's go ahead and insert this entity. So em.insert time off, which will also return me a time off. And just to see the input and output, let's just print those on the console. All right, so again, just to walk you through, all we are doing is creating a new time off, but time off, we want to maintain it as, uh, we want to specify who the owner is or who the parent is, and that's going to be an employee. So we're just setting that employee as the parent key. Let's call the insert method now. And now let's run it. Okay, so we did send a time off with that value. Notice ID is still 0 here, but the returned value has an ID. And let's go back to the Cloud Console and check our time off entity. Okay, now notice there is an ID, but then there is also a parent. The parent is key the parent's key is employee, and that's the ID of the employee, and then we have still our properties. So from here you can just click and go to the employee record if you want to, which is nice for testing purposes. Now, if you want, the parent-child relationship is not just one level. It could be a multi-level hierarchy. For example, uh, you know, a user has his files, let's say, and files are organized into directory structure, just like on the file system. So you can have user as the root level entity, and then directory, subdirectory, subdirectory, and then files. So you can go as many levels as you want. um, Now, one thing to keep in mind is when you are using entity groups or ancestor keys, your database queries are strongly consistent. um, in other words, with root entities, your queries may not always reflect the up-to-date data. Um, However, if you are using an ancestor query, then you are always guaranteed to get up-to-date data. With that, I'm going to conclude this session. Thanks for joining me, and we'll see you back in the next session.